topic for our group project for course CSC510 is rules of inference. There are 4 members in our group members, which are Nasrul Azri bin Ahmad Sazali, Nur Hijrah binti Muhammad Zamri, Muhammad Alif Ruzaimi bin Razali, and Anis Shafiqah binti Zamani.
Hi, I'm Nur Hijrah binti Muhammad Zamri. I will start my presentation with the project we have chosen, which is question 1, related to rules of inference focusing on propositional logic. The input for testing given here are Ali works hard. If Ali works hard, then he is a dull boy. And if Ali is a dull boy, then he will not get the job. The desired conclusion is Ali will not get the job. As for the output, we need to state the validity of the statement together with the law used. Now, let's look at the problem statement of this project. The difficulty lies in determining the truth values of the propositions used for connection, as well as the impact of these rules on the consistency or inconsistency statements in arguments and other logical relationships. For example, students manually entering statements can easily make mistakes, leading to inaccurate results. Therefore, we develop an inference engine that converts hypotheses from English statements into propositional logic according to the 8 basic rules, such as modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunction, as well as resolution. It allows users to choose and apply particular rules of inference to these statements to determine their validity. By developing this system, users can reduce errors and enhance efficiency.
Hello. So here I will explain about our system. Our system is about rules of inference that has been made by DevC++. So here I will show our full coding. So first, our class is about inference engine, that is define the calculation of the rules of inference that will use to calculate the statement that input by the user. So for void display premise is for display at the user before they can input the premise that they want to insert into our system. Then this is a define the return for the premise, and here is the output that will shown for user to insert the input that they want to key in. So this is the calculation for the premise that will calculate, and it will go to the engine of each rules of inference. So after the system calculate, it will determine whether the statement is valid or not valid. So here I will show how the system run. So first we run it, and it will show the display that I just explained to you. There is a little number of premise and the list of the rules of inference. So first we need to enter the total number of the premise that we want to define. So for the testing I will use 2, and the premise number 1 I will choose negate q, and for premise number 2 I will choose number 7. And for the rules of inference I want to use the modus tollens, and for the statement P I will use Ali works hard, and for Q, Ali is a dull boy. So if we don't have the statement, we just can skip it. And for the conclusion, it should be negate P. So if we click the enter, if the system will calculate and show whether and will determine whether the statement is valid or not valid. So as you can see, it shows the statement P is valid. So now I will show that the system also can determine the statement is not valid. So we will use the same input 5, 8, and premise 1 for negate q, and premise 2 is number 7, and the rules of inference, we use the modulus tolerance, and Ali works hard. Ali is a dull boy. So if we put the wrong answer, we will give B. So as you can see, you define the statement P is not valid. So that's all from me. Thank you.
My name is Nasrul. For this part statement, I present about project limitation. So there has three, which is user dependency, interface challenges, and fixed inference rules. For the first one is user dependency. The correct selection of premises, rule numbers, and conclusion statements relies heavily on user input. User must manually input premises, rule number, and conclusion, which could lead to errors and or incorrect interpretation if not handled properly. For the second one is interface challenges, which is the user interface assumes familiarity with logical notation and require users to interact by inputting specific premise numbers and rules number. This can be challenging for users who are not accustomed to a formal logic notation, potentially hindering usability. The last one is fixed inference rules. The engine is limited to 8 predefined rules of inference. This restricts the flexibility of handling a broader range of logical rules or custom rules that might be necessary for more complex reason tasks. Thank you.
For example, Ali works hard in premise 1, Ali is a dull boy in premise 2, and Ali will not catch up in premise 3. We can conclude that the rules of inference from the three premise is hypothetical syllogism and it is valid.